Hello, Fruitport High School AP Chemistry students. Another lesson for you. It's our last lesson in this empirical formula, molecular formula, percent composition situation. And this one here has a reality of what happens in labs, at like professional labs that we have to consider. How do we get those percent compositions in certain things? A white powder is found at the scene of a crime, and they want to test it out to see if the white powder is a poison or maybe it's an illegal drug. And so, how do they work with that here? And so, let me show you this map again here, this little flow chart that I created to help us get from percent composition to empirical formula, molecular formula. And this is the key here, is sometimes we won't get percent composition, but we'll have some lab numbers. And from the lab, you can get grams to start the process of getting formulas. Okay? And now, when the copper iodine lab that we did in class, we actually measured copper, we induced measurements of iodine, and then we were able to get grams of copper, grams of iodine, and then work our way to moles into a ratio. Okay? So, but this next part is talking about combustion reactions. And so, do you remember combustion reactions from chemistry class? Combustion reactions are when you take something organic, like organic chemistry always has carbon compounds, and you burn it with oxygen, and it makes carbon dioxide, and it also produces water. And so if we have a substance, I put X and Y here to kind of imply that we don't know the actual numbers because we're going to try to figure them out. And sometimes the combustion reactions can also have some oxygen in them. Here's some CXHYOZ, but we still get the same reaction. But sometimes we might have another compound like nitrogen or chlorine, and we'll still burn it with oxygen, we'll still make carbon dioxide, we'll still make water, but you might have to make a third compound because clearly if you have nitrogen and these two things don't have nitrogen, you need some compound with nitrogen, and it depends what compound it makes. Not so important for us today. So what will happen is that we'll take a certain number of grams of this, right? Maybe I shouldn't put a question mark. You'll know the number of grams of this, and you can actually figure out how many grams of carbon dioxide came out. So you put in some of this into the equation, and then it gives you carbon dioxide, and it gives us how many grams of water. And so you're going to use these numbers to get us started. But it's a little bit tricky here. So let me show you a device of how this kind of works in the lab. So if you have this combustion device, what you'll do is you'll take your unknown organic compound. You'll know how many grams. You'll put it in a first chamber that acts like a furnace, and you'll pump oxygen in. And when oxygen and this compound are near each other, they will react, and they will go through the combustion reactions that we just talked about on this page. You're going to make carbon dioxide, and you're going to make water. And the combustion device is set so everything flows in this direction. And after the first chamber, you come to a second chamber, which has like essentially a sponge for catching water. And the sponge will absorb any water that was created from the reaction here. And if you weigh the sponge beforehand and it weighs 3 grams, and you weigh the sponge after and it weighs 3.5 grams, you know that the sponge absorbed half a gram of water, and you can use that number. Well, then all the products continue to another chamber, which has some kind of absorbent powers of carbon dioxide, a sponge that will absorb the carbon dioxide that you made. And they use different chemicals, and you weigh it before and you weigh it after. The sponge is oversimplifying it. And then all the extra oxygen will come out. And if a third chemical is made, it will come out too. But the point of this is that all of the carbons you start with turn into carbons in the form of carbon dioxide. And any hydrogens you started with turn into the hydrogens that make up water. Okay, so that's a big explanation for the last slide, which might be the only slide you care about. How do you take grams of carbon dioxide and grams of water and get to this part here? Because these grams are grams of a regular old element, not a compound, not carbon dioxide and water. So here is the trick. To convert grams of carbon dioxide into just grams of carbon, we use this conversion factor. So that conversion factor is based on molar masses. You will always take 12 over 44. So the grams of carbon dioxide cancels grams of carbon dioxide, and there's 12 grams of carbon in 44 grams of carbon dioxide. So whatever number you're given here, you'll just multiply by this ratio of 12 over 44, you hit equals, and we'll now know the answer in grams. Something very similar for water. We take the grams of water and we multiply by 2. That's because there's 2 hydrogens and an oxygen. Each hydrogen has a mass of 1 AMU. And this is the conversion factor, how to convert grams of water into grams of hydrogen. Okay. So the first homework problems that you're going to see in this next question of book problems is they'll give you grams of an element, right? Or they'll give you percent, and you will use this just like we had been practicing, okay? But the last problems, the hardest ones, is you'll read a question and it will says, upon combustion of an unknown sample, you yield, and they'll tell you this, a certain number of grams of carbon dioxide and a certain number of grams of water. And from this, you can use the green notes to convert that into what we need, grams of carbon. And then you can use the blue notes to take the number from the problem to get to grams of hydrogen. And once we have grams of carbon and grams of hydrogen, I'm not going to review in this video how to do the rest of these steps. You can look at the other videos. But now we can start. The last trick here is that what if you only have a compound that's C something, H something? Hey, you got grams of carbon, grams of hydrogen, you're good to go. But what if you got like another element in there? How do you get the grams of oxygen? Well, you will know that the grams of carbon plus the grams of hydrogen plus the grams of oxygen should equal the total grams of the compound. So if you know this number and you know this number and you know this number, you can use your algebra skills to get grams of oxygen. I imagine there'll be some questions on this. We will spend time Monday and Tuesday taking a look at your homework questions, and it might be like half notes, half homework questions, but we'll be in a good spot. All right, good stuff.